Hi, I've been working on a trajectory calculator or a distance calculator, whichever you'd like to call it. It is based on Alan Nathan's trajectory calculator, which is an exceptionally accurate calculator that he based on batted ball data for Major League Baseball games. I've been trying to add more value and user experience on top of that calculator. So I will tell you what I've been working on, and I hope you find it useful. Okay, so up here you can select the park you'd like to look at. You can search by either the team name or the name of the park. I have all 30 parks here plus the Polo Grounds, just for fun. I will select Yankee Stadium, just for fun. Okay. Next, you will see this autofill environment data. When you select a stadium, it will automatically fill in elevation data, and that's why this is marked red here. In fact, all over the all over the spreadsheet, the color red basically means it is auto-filled in. So all of these on the right over here, these are all the basic constants and whatnot that you don't want to touch. If you touch those, you'll break the calculator. And over here, you have the real wall distance and the real wall height at the targeted projected angle on this. Anyway, we'll get to that in a second. So anyway, red means it's auto-filled. So elevation is automatically filled in regardless of what you do, because obviously elevation, the stadium isn't moving up and down. So anyway, so temperature, humidity, and pressure obviously change all the time, and you may not know the temperature and pressure or whatever for a given city. So I have filled in this autofill feature, and it means that for temperature, it has the average temperature of ball games supplied by Major League Baseball, and for humidity and pressure, I got the data from Wolfram. And I don't know exactly how accurate the data on Wolfram is, but it's at least a starting point, and you can change this data as you see fit by turning off this autofill feature. If you keep it on and edit those numbers, then it will automatically switch back to the autofill version. Anyway, next you have the exit velocity, the vertical angle, and the spray angle. Velocity and the vertical angle are supplied by Major League Baseball. The spray angle you will have to estimate yourself, and that's always fun. Backspin, side spin, and gyro spin. These spin rates are not supplied by Major League Baseball, and these are exceptionally important to finding the true trajectory of the ball. However, there's a slight trick that you can do to find the backspin, and the side spin and the spray angle you pretty much have to estimate by eye. The backspin, though, you can use this Z coordinate to find the maximum height of the ball, which Major League Baseball often will supply, especially for home runs. They'll tell you the maximum height of the ball and also how long the ball stayed in the air. So it's like maybe 4.1 seconds or whatever. So you can use this time and this Z coordinate, and you can dial in the spin rates to get as close as possible to your expected Z and time supplied by Major League Baseball, and you can use that to dial in an estimate for the spin rate. Anyways, so next you have the target height, which is how high above the ground that you care about. You might set it to the height of the wall, for example. You might set it to the height of a fielder, or you might set it to 0, and you say, like, you only care if the ball bounces off the ground. But anyway, these distances, how far the ball will travel, it's how far from home plate the ball falls to this target height. So this target height changes these numbers pretty significantly. Okay? Anyway, so the real wall distance and the real wall height are measured from this projected angle, which is found, the projected angle is a combination of the spray angle plus the side spin, and plus the wind. So anyway, so the projected angle will, it will round the projected angle to the nearest integer, and then it will find the real wall distance and height at that angle. It is rounded to the nearest 1 degree, so that is something to keep in mind. Although I think the nearest 1 degree is I think it's a pretty good standard. Anyway, so the wind direction and wind speed. By default, I usually keep this off, but you see this line will point in the direction. So the middle dot is, just the middle of the circle, and it will point in the direction that the wind is blowing in. Okay, so and the length of this line will indicate how fast the wind is blowing. So 5 is about that long, and if you set it to 0, which is I usually have this turned off, then the line will get shorter and the trajectory will change. Anyway, so that's that. These projected distances, the low is, I believe it's about 2 standard deviations below average distance, based on, anyway, the standard deviations are coming from the coefficient of drag and the coefficient of lift. So we're saying, each baseball is manufactured to have, and they, let me try again. Each baseball is manufactured to a standard whereby there are a lot of different possible coefficient of drags on the ball. It's just because of random chance when you're manufacturing the ball. They can't all be perfect, and also they're made of natural materials which have natural variance and whatever. So some balls have higher drag than other balls. So this low number in red that represents balls that have significantly above average drag, and this high is significantly below average drag. So the high is the high is the high end of how far you expect the ball to go, and the low is the low end of how far you expect the ball to go, and the blue is roughly average on where you expect the ball to go. So this will give you a respectable range. Like about 90% of balls hit on this trajectory with this info, about 90% of them will land between the red and green line. Anyway, although that is like about 90%, keep that in mind. So that means 10% will land outside, and that's what this estimated home run chance is doing. It is measuring where these lines cross the top of this wall, how many balls you would expect based on this data to go over the wall. Okay, so yeah, I hope that makes sense. You can view the formula here. It's not especially difficult, but anyway, did I just mess that up? I think I messed it up. No, I didn't. Okay. On this printout, this black line represents the wall. The distance, and then the distance to the wall, the height the ball travels, blah, blah, blah. The vertical angle and the spray angle. And that's pretty much everything on this page. I have the second page here, which is just a little bit blown up. This shows you just the bigger spray chart, the vertical angle, and the wind again. So, this is, I don't know, this is a project I've been working on for a long time. I'm glad it's pretty much done now. All of the stadiums are in there that I wanted to add. I may in the future go through and add minor league stadiums, but that is a lot of work, and I don't know if I feel like it. But I hope that this information, I hope you find this useful, and you can use it to analyze batted balls, compare stadiums. You can do all sorts of fun stuff, and I hope you enjoy it. Goodbye.